We begin our unit on polynomials with more factoring. When factoring, we always look for the GCF first. There are other patterns to look for when factoring two-term problems. A squared minus b squared, if it's in this form, then our factors are a plus b times a minus b. Sum of cubes, then it's a plus b times a squared minus ab plus b squared. And then we have difference of cubes. There's a minus sign in between. And if our expression is in this format, we factor it a minus b times a squared plus ab plus b squared. A perfect cube is a number or letter or variable multiplied by itself 3 times. So let's look at some perfect cubes. The cube root of 1 is 1. The cube root of 8 is 2. The cube root of 27 is 3. The cube root of 64 is 4. The cube root of 125 is 5. The cube root of 216 is 6. Let's look at some variables. The cube root of x cubed is x. The cube root of x to the 6th is x squared, and so on. So let's factor these problems using our formulas. X cubed plus 8. This is a sum of cubes. The cube root of x cubed is x, so we're going to let a equal x. The cube root of 8 is 2, so we're going to let b equal 2. And then we're going to put it in the formula for the sum of cubes. If you had to remember this formula, the first sign is always the same as the original. The second sign is always the opposite, and the third sign is always positive. So you can remember it with the acronym SOAP. Same, opposite, always positive. Now let's just put in our a and b into the formula and we're done. A is x plus 2 times a squared. Well, a squared is going to be x squared minus a times b, so that's 2 times x, plus b squared, which is 2 times 2, so that is 4. So this is our answer. Let's go ahead and look at example 3. In this case, it is a difference of cubes because of the minus sign. The cube root of 27x cubed is 3x. The cube root of 64 is 4. This is difference of cubes. Now let's just fill in the information. A is 3x minus b, which is 4, times a squared. Well, a squared is 3x times 3x, so that's 9x squared, plus a times b, 4 times 3, that's going to be 12x, plus b squared, which is 16. And this is factored. 5 is going to be a difference of cubes as well. A is equal to the cube root of 1000x cubed, which is 10x. B is equal to the cube root of 1, which is just 1. Let's fill in our information. A is 10x minus b is minus 1 times a squared, which is 100x squared, plus a times b. 10x times 1 is 10x, plus b squared, which is 1. Let's look at 4. First, we want to take out the greatest common factor. In this case, it is 16. When we pull 16 out, we end up with x squared plus 4. This is not a difference of squares. This is not a difference of cubes or even a sum of cubes. So therefore, this one is done. Now let's look back at number 2. Take out the GCF. In this case, there's not one. And this right here looks like a difference of squares. Now, difference of squares follows the pattern a plus b times a minus b. So a is the square root of x to the 4th, which is x squared. and b is the square root of 81, which is 9. So this is x squared plus 9, x squared minus 9. We're still not finished. I cannot do anything with x squared plus 9, so I'm just going to bring it down. But x squared minus 9 is also the difference of squares. A is x and b is 3. So this is times x plus 3 times x minus 3. Now we have some more factoring to do, and this time we're looking at factor by grouping. When we have 4 terms, we want to factor by grouping. Group the first 2 terms and the last 2 terms and factor out the GCF. For number 6, we factor out the GCF first. And there's not one other than 1, so we're done. Next we group, leaving a positive sign in between the 2 groups. Now we pull out the GCF of the parentheses, of each parentheses. So the GCF in the first parentheses is x squared. What's left over is x minus 4. How do I get that? Well, when I divide by x squared goes into x cubed, x times, and x squared goes into 4x squared, 4 times. Now let's factor out the GCF in this equation, and that is 2. So if I divide both of these terms by 2, 2 goes into 2x, x times, 2 goes into 8, 4. Notice that these two are the same. That will be my first factor. What's left over, the x squared and the 2, pulls out, and that becomes another factor. Now I do need to check to make sure I can't do difference of cubes, difference of squares, sum of cubes. This one is already done. And this has a square here, but it's not a difference of squares. So this is complete. Number 7. Very first thing is take out the GCF. Next thing is grouping, leaving a positive sign in between the 2 groups. Now we take the GCF out of each parentheses. So the GCF of the first parentheses is x cubed. When I pull an x cubed out of each term, x cubed goes into x4 1 time. X cubed goes into 2x cubed 2 times. The greatest common factor between 8 and 16 is 8. So let's divide both of these terms by 8. 8 goes into 8x, 1x times. 8 goes into 16, 2. Notice these two are exactly alike, and that I will pull out front. What's left over gets pulled out and goes into the other parentheses, x cubed plus 8. Now I need to check and see if either of these are difference of squares, difference of cubes, or sum of cubes. This first term is already complete. The highest degree is a 1. So let's move to the second term, x cubed plus 8. This pattern is a sum of cubes. So let's put it into the formula. Remember that formula is a plus b times 8 squared minus ab plus b squared. First term stays the same, x minus 2. The cube root of x cubed be x, so that is a. The cube root of 8 is 2. So let's put this inside our parentheses. This is a is x plus b, which is plus 2, times a squared, which is x squared, minus a times b, which is 2x, because 2 times x is 2x, plus b squared, which is 4. because 2 times 2 is 4. You try number 8 and check your answer with mine. So you should have gotten x plus 3 times x plus 4 times x minus 4. Remember that if there's a negative out front of in your parentheses, that you need to pull that out. And this gives us a difference of squares. Now try number 9. You should have gotten 2 times x plus 2 times x squared minus 5. The x squared minus 5 is not a difference of squares, so we're done. Now let's look at a different type of problem. Factor the following completely. We have 3 terms again. So this is just like ax squared plus bx plus c. And I'm going to do this 2 ways for you. We'll do it with the snowflake, and we'll do it factor by grouping. See this x to the 4th? If I change this and let x to the 4th be equal to x squared, and x squared be equal to x, then what I have is x squared minus 5x plus 4. And this is very familiar. If I do the snowflake, x times x, my ax's go here, a times c is 4, b is negative 5, and the 2 terms that multiply together to give me 4, but combine to give me negative 5, are negative 4 and negative 1. But remember, we let x squared equal to x. So this is x squared minus 4 and x squared minus 1. I'm still not finished because x squared minus 4 is a difference of squares. So this is x plus 2 times x minus 2. And x squared minus 1 is also a difference of squares. So this is x plus 1 times x minus 1. And that is your answer. Let's look at it one more time, but this time let's factor by grouping. This is x to the 4th. We're replacing negative 5x with squared with negative 4x squared and negative 1x squared, and then adding 4. Now factor by grouping, and we pull out the GCF, and the GCF in the first parentheses is x squared. That leaves us with x squared minus 4. In the second parentheses, I pull out a negative 1. That leaves me with x squared minus 4. These are alike, so that becomes one of my terms. The x squared minus 1 are what's left over. And then these are difference of squares, x plus 2 times x minus 2 and x plus 1 times x minus 1. So we get the same answer. It does not matter which way you look at it. Now you try number 11. You should have gotten x squared plus 6 times x squared minus 3. I have shown both ways to look at this so that you can look at it either way.